Hey everybody, it's Mr. C. Got little David over here, and today I'm going to derive the quadratic formula. So this time I'm gonna have to go a little slower than usual, but this is one of the most important topics in Algebra 1, and hopefully we'll just have to do it one time. So here's what happens. The standard form of a quadratic function looks like this. You have ax squared plus bx plus c equals 0. That's the standard form of a quadratic. If I said function, I meant equation, a quadratic equation. So what I really want to do is I want to solve this for x. And why I want to do that, I don't know. Somebody sometime thought, hey, I wonder what would happen if I solved this equation for x just to see what happened with the a, b, and c. And a lot of times in math, we have a lot of really good discoveries and math being done by just saying what if, and then somebody tries it out to see what happens. And sometimes you get really surprising results. This time, I'm going to attempt to get x by itself. And notice that I have an x squared here, an x here, and no x in this term. So I cannot take an x out. My only real option right now is to try and complete the square to see if I can solve this for x, because I know that works, right? So here we go. If you complete the square, the first thing we learned that we need to do is get rid of this a right here. And we want to keep these two terms, and we can even move the c to the other side. So what I'm going to do is I'm going to just say ax squared plus bx equals negative c, all right? So I should probably do this really slow. Then I'll need to get rid of this a right here. And I know I have a b in the middle, so what would that look like if I got rid of the a? And by that, I mean factoring it out. Let's try this. A times x squared. That would certainly give me ax squared back. Now, right here, I'm probably going to need something like b over a. Because if I multiply a times b over a, the a's will cancel, and I'll get my b back. And that's what I want. Plus b over a x. Now, again, we need a blank, so plus blank, because we are going to complete the square, equals negative c. And this time, I'm introducing an a times blank over here, so I need to put the same exact a times blank over here because it is an equation, it's not a function. And so I'm just going to add it to both sides, a times blank. Okay. Now, I'm going to go ahead and do like usual. I'm going to take b over a. I'm going to divide it by 2 and square it. Well, what happens is we find out the a will drop down with the 2 and multiply. So it really is b over 2a squared. Okay, if you square the numerator and then square the denominator, you'll get b squared over 2 times 2 is, or 2 squared is 4, 4a squared down here. That is what goes into two blanks. And I know it doesn't look good at all, but let's see what happens. So I'm going to put a b squared over 4a squared and b squared over 4a squared. All right. Now, all of this needs to be cleaned up. This is now a perfect square, if you can believe it. That is a times x plus b over 2a squared. This over here can be cleaned up a little bit, equals negative c plus, all right, if we multiply a times all of this, that a here and one of those a's down here are going to cancel out, and it's going to leave b squared over just 4a. Okay, now that I'm going to hang on to because I've run out of room. So I want a times x plus b over 2a squared equals negative c plus b squared over 4a. Okay, generally, before I start dividing by a and doing all that stuff and taking the square root, I'm going to clean this up a little bit over here because I want to get these two terms together. If I get those two terms together, I've got a negative c and a b squared over 4a. I've got to multiply this c by 4a over another 4a. Okay, so I'm going to do that over here. Negative c times 4a over 4a. If I do that, that will give me negative 4ac over 4a. Okay, and that is going to be added on to the b squared plus 4a. So here we go. A times x plus b over 2a squared is equal to, remember this became this, negative 4ac over 4a plus b squared over 4a. These two terms now have a common denominator, so they can be added together, and you can combine the two numerators. And so what I'm going to do is I'm going to say a times x plus b over 2a squared equals, normally the b squared would come first. I can write b squared plus, or b squared minus 4ac. That's fine. B squared minus 4ac over my 4a. Okay, now I can go ahead and divide both sides by a. If I divide both sides by a, that a is going to travel down here in the denominator. You've already got 1 there, so it's going to be an a squared when I get done. So this guy is going to go down here and make that a squared. So I have x plus b over 2a squared equals b squared minus 4ac over 4a squared. All right, now I can go ahead and take the square root of both sides. If I take the square root of both sides, I'm going to get x plus b over 2a equals plus or minus square root of all of this, b squared minus 4ac over 4a squared. Now, as you can see, I've run out of room again. So now, we're not going to erase that at the bottom because I'm going to need that. I'm going to now put that up here. X plus b over 2a equals plus or minus square root b squared minus 4ac over 4a squared. Okay. If you remember from your rules of square roots, you can take this fraction and split it up into the square root of this guy over the square root of that guy. It's perfectly fine to do that. So I'll do that over here in my scratch work. So I'm going to split it up into the square root of b squared minus 4ac. Okay, so that's just going to be a square root all by itself, divided by the square root of 4a squared. The numerator, you can't do anything with that. It's there, okay? You can't simplify it. It's not a difference of squares. I mean, even if it was, you couldn't do anything. This down here, though, is a perfect square. So the square root of 4a squared is actually 2a. So all of this is actually going to be rewritten as the square root of b squared minus 4ac over, I need lots of room here, 2a. All right, so now I'm going to take this guy right there and I'm going to take this and put this in that place. So x plus b over 2a equals plus or minus the square root of b squared minus 4ac. Okay, we need to go ahead and put that there over 2a. Now the good part of doing this, of simplifying this, is that I now have a common denominator here. So when I move this b over 2a over, I'm now going to get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac, all of that is a perfect square, or I mean square root, sorry, over 2a. I can combine this into one expression now, and x equals negative b plus or minus the square root of b squared minus 4ac, all of that, all over a common denominator of 2a. And that, ladies and gentlemen, is the so-called quadratic formula. If you know a, b, and c, the three coefficients of your quadratic equation, you can plug those numbers in, here, here, there, there, and there, crunch it down a little bit and simplify, and you will get your two solutions, no problem, every single time. Even if they're going to be imaginary, you can still get them, and we would do that in Algebra 2 and courses above Algebra 2. So this is the crown jewel of Algebra 1, the quadratic formula. That is so, so important. You can replay this video anytime. You can get the whole derivation here. Hopefully this has been insightful, and you're not too intimidated by this, but you will be using this a lot in your next few math courses. So from here, this is Mr. C and Little David logging off, and have fun with the quadratic formula. See you guys.